So, hello everyone. This is today's LeetCode contest fourth question. Generally, I don't cover fourth question because my audience like till third question only. But this is another beautiful problem. I liked it. In the contest itself, I was not able to think about that. But when I think about this problem, right, this remind me of something, of small things, how make a large difference. So this is eventually tagged hard, but as our motto is to make every hard problem to medium or even easy. And we have done that in past as well. And we will do it today as well. It's just the hard implementation wise. Thinking wise, it's literally easy. I will tell you the concept. It's not too difficult. The implementation is quietly not actually hard, but it's a medium to hard. Right. So that is the story of this problem. And if you are liking till here, so please subscribe to the channel and make sure to hit the like button, and let's get started. So cool. Firstly, let's try to understand. See, whenever you see a hard problem, right, even in contest or while practicing itself, don't try to lose your calm. You can solve it. It's not always a hard problem is always a hard problem. If you solve a hard problem, right, you will gain more and more confidence. Think like that. If you can solve a hard problem, you can solve an easy and medium problem easily, right? So don't get afraid. First of all, don't run away. That's my motto. Is that's why I cover more and more hard problems on my channel as well in OA series, and you can check that out as well. So you're given a non-negative integer, and okay, and we have to it's called a binary palindromic. If binary representation without leading zero, read the same as forward and backward. Okay, that is fine. That is fine. And then return the number of integers k such that the binary representation of k is a palindrome. Number of zero is considered as binary palindromic, and zero is also considered a binary palindromic. Okay, single elements always be considered as binary palindromic itself. And this is a certain example. Let's say you have 9, then 0 is a palindrome, 1 is a palindrome, 1 is a palindrome. All the number lesser than 9, and we will convert to their binary representations, and then we'll compute that. Okay, 1001 is also a palindrome. What does the first thing comes to your mind? We always talk about intuition, then we'll think about my intuition, and then how can you think about that, and then we will jump to the solution. Okay, first solution that comes to our mind is obvious, right? O of n solution. We'll iterate, and then what we'll do, we'll check the binary is a palindrome, right? So these are almost constant expressions, right? The main thing is the loop itself, but the n is not till 10 power 9, it's 10 power 15. It's huge, not very huge. So we cannot do that, right? So you straight away lose this idea. What the other thing comes to your mind? What comes to my mind during the contest? I was not able to execute it because that won't work because the constraint are too high. Okay, it was around 10 power 9, I would have been able to solve that, but it's 10 power 15, so that's the figure. So what I was thinking was, what you can do is, and also let me know in the comments and if you thought about this approach. I think most of you will think about that. Okay, because my audience is smart enough. So what I was thinking is, palindromic, we have solved some similar kind of problems like this. So what we will do, we'll only talk about the left half. The right half will be obviously the mirror of this. And they are one more possibility of making an odd palindrome. So basically maybe putting 0 or 1. So what I was thinking was just construct all the half palindrome, not palindrome, but numbers and into binary. And then what we will do, will contain a set. You have to contain a set because if you contain a vector, it may lead to duplicate values as well. Okay, so I won't be focusing much on this solution, but I will give you just what I was thinking. So what you do, you run a for loop here, not now. That means, because see, this is around 50 bits, 50 to 50 bits. Okay, if half is also 25 bits, so you cannot do that. Okay, here, but let's say the solution was if n was to 10 power 9, then it was 30 bits, and then it was 15 bits. So basically our 15 bits we can solve this, but this, since it was that huge, we cannot do that. So what I was thinking of, just what you do, you make everything binary. I less than equals to 2 power 15 I plus plus, and you maintain a set, and you put all the three possible binary you can get. What is the three possible binary? First binary possible is the half, plus reverse of half. This is the even wala case, right? And there could be duplicates. That's why you have to maintain a set, right? Always, and you have to put in into an integer form. Okay, because that would be better. We will be comparing at the end while running a for loop. Okay, and this is one case. One case is you do half plus zero plus reverse, and the third case is, I think most of you have thought about this approach. I'm pretty sure about it. But yeah, if you had, please drop into comments because many people commented, and I like that. That okay, we are thinking in the same direction. It's not wrong, but yeah, it's not much optimal as per the problem required. Okay, this is the possible. So basically, what will be our time complexity of the solution? 2 power 15 into 3 per move. So yeah, this would have been passed. This would have been passed. But this is not the case here, right? 2 power 25 is very huge, around 10 power 8 and more than that, and it won't pass. So this solution won't work. And I have to drop my idea, and I was not able to solve it. But now I was thinking about this solution. Okay, cool. This two ideas I think about. Let's discuss about the third idea, which is the optimal idea, that how can you solve this particular problem. Okay, let's talk about this. So what I was thinking is, okay, why not, let's try like this. Let's construct and how many palindromes we can build out of by considering each length. So let's calculate the length of the number first. Length of n, you can calculate easy, right? Just the number of bits of n. Okay, this is length of n in binary. This is simple. I hope you got it. Right, what is the next step? This is the number of length we possibly could have. So we will start with one and we will go till this max bit, you can say that. Okay, let's say the case is 9. So we'll go with this example. So the case is 9, then we have 4 is the max bit, right? Because the binary representation is 1001. Okay, and then we'll construct each length palindrome. Okay, each length palindrome, and we'll see how many we can get in log n time. Obviously, see, this max bit will go up to log n. Okay, and then for each query also, we cannot go to up to n as well, right? We have to again sort of think of a log n thing, sort of these kind of solution I want. Okay, cool. Now let's consider, okay, we are at length 1. So what I will do, I will use a very good idea. What I will do, I will do a binary search. What binary search will do? We'll do a binary search over all the numbers, all the numbers of the range in the given bit length. Okay, very nice idea, very nice idea. You should think about this in this direction. And if you start thinking, you will start understanding things. Oh, yeah, right. And then what I can do? It's very simple, right? What I will do? I will do the left half. I will make through it. And then what I will do? Tell what you can think, right? What you can do. You let's say, and I will, what's the range, first of all? Let's try to discuss first. So let's say my length of the palindrome I'm considering is 4. Okay. Then I will divide. Firstly, I will construct only the left half first, and then we'll construct the right half. Okay, so let's say the left half is of 2 lengths, and right half we will mirror it somehow. Okay, that's very easy, not a difficult task. So 2 is this. Now what I will do, I will, what is the maximum number you can get of through 2 bits? That is 3. And what is the minimum number? That is 1. It's 0, 1. That's the minimum number of bits we can go through, right? Oh no, sorry, not one. One. Sorry, it's two. 1 0. Because leading 0 is not considered. 2 3. Right. So that's the range. 2 3. Now this is the left half range, and now we have to binary search over this range. That what is the maximum possible value of this left half that we can consider, and we can make a complete palindrome, and that should be. I do think it should be less than equals to our original length, right? Then only we'll consider that. After that, if it start going ahead, then we won't consider that, right? This is the main thought process. So we will find the left half maximum possible value we can get. which is less than it. We'll make the complete palindrome. We'll see how we'll make it. But yeah, that's the basic intuition. Then what we'll do? That what we'll do. How we calculate the number of occurrences, like how many palindrome we can get from here. Try to think about that. So we have started with a start range. We started with the end range. Okay. And let's say we found a mx, the maximum number between this range. That is, if you form a palindrome through that, and then we will get that. We will consider, we can consider till s to mx, right? That's our range. All are valid. If mx is valid, obviously this is a binary search on answer type question, right? Mx is valid, mx minus 1 is also valid. So count plus equals to, try to write in comments if you can think about this. This is nothing but the range mx minus s plus 1. Means for this bit, means bit length, I am considering how many palindromes I can get through that. And I am getting this in log n. I'm not iterating on all the possible palindromes. I'm doing this, just finding mx and this. And this is, since is a monotonic thing, you can think about like that. It's a beautiful question and beautiful idea. If you think about this, okay, here it is fine. Okay, okay. I got the gist. So basically, what we are doing essentially is we are calculating first the max bit, iterating over all lengths. I know it's a bit lengthy question, I say. It's not difficult, it's lengthy over all lengths. Then we will find the max possible num for that bit length, for that bit length. That will make a palindrome, and less than n. That will, it's like a check function we have to implement. That's only remaining. That will make a palindrome, but less than n as well. This is also a condition. And less than, because less than n is the major condition, like less than n. Okay, till here it's fine. Okay, now, and what we'll do, I will consider how, if we found the mx, we'll calculate this and we just return the count, right? I don't think so. Till here, nothing is hard, right? And now it's not a easy, it's only the check function implementation is remaining. So what we have to do now, see, I will write a, a palindrome function, or maybe you can say solve function. What it will take? It will take the whatever the mid value we are sending in a binary search, we send mid value, and also the length of the palindrome we have to make. Okay, okay. Then what we have to do? And also, I have shown a very beautiful way to uh, mirror the thing. That's also very interesting. Please hit the like button for that thing as well. Like, I loved it. Means people what generally doing was converting it to a binary and then again converting into a number. It was very tedious. I will show you a very better way to do that. Okay. So what you can do, solve and this, then we'll initialize. Now, what essentially we need? This is our left half. We have to construct and mirror the right half. That's all of that length, right? From the mid, we have just to construct. There's a very easy way, right? Just convert into binary. And if it is a length is odd, then you don't need to mirror the last bit, right? Let's say the length is 7, and then the mid you got is like this. So you have, sorry, not this, but like this. So you don't need to mirror this. So mirror only this part, right? This you have to do. So this also very simple, right? But I will show you a very good trick to do that without binaries converting, just using the bit manipulation tricks. Right. So what we'll do, we'll initialize our answer, which will consider our final palindrome, which is will be initialized with mid only. Okay. And also I am initializing one more k, which is also which want to mirror, from which we want to mirror the right half. And then we'll construct from it, and it's also mid only. And now we'll check if our length modulo 2 is equals to 1 or not. If it is equals to 1, that means what we'll do, we'll shift the k to 1. Why we are shifting to k to 1? Because we don't want to mirror the middle bit, right? Not middle, yeah, like the last bit. Let's say this is 0, 1, 1, right? I don't want to mirror this. I just want this. And then this will be already available. Why? From this answer. We'll get this. So we don't need to mirror that. That's the idea. Then what we'll do? That's a very good trick. Let me just show you itself in the code itself. So what we will do, it's this is the code. So here we calculate the length by 2, right? Because already left half we already have. This is the inval we already have. And the right half, what we will do, we're copying like this. Let's say this is 101 and we want to mirror it, right? So what we'll do, we'll calculate the ith bit from the right, and then we are just pushing like this 1011. We're shifting our answer to this, and we're doing an or with one. If the bit is set, it will be set one. And it will copy in the reverse direction. If you see, this will be copied. This will be copied in the reverse direction. And I'm assuming the length to be 7. So I'm not copying this. I will copy this. Okay. So this 01 will be done. Will be copy from this and this. The middle bit won't be copying. Right. So this is how we will do it. If you can think about, if you go further, right? This is our, let's say this is our first step, right? 10111. We got our answer, right? Now what we'll do again, we'll shift and we'll check whether this the ith bit. Now this bit, which bit? Uh, this one, right? Our firstly already shifted by one. Why? Because the length was odd. We already shift k by one. So this is our original. And now the second bit is not set. So what we'll do? We'll do 110, and we don't do anything right here because it's or with zero. So it will be 11110. Now the last bit remaining, this bit, and this mirror it this reverse bit, right? So this was a very good trick. This is a check function to construct the palindrome. You can do with the binary itself. This is a very cool idea. One more thing I just want to tell you guys is this thing. Also, yeah, let's try to discuss the ranges. How will we discuss the ranges for particular bit length n? Let's say I. Okay. So firstly, uh, let's try to consider that. How will we consider the maximum? We consider only the half bits, right? So firstly, we'll calculate the half. Half is I plus 1 by 2. Okay. And what is the minimum number we can get from this half, which is nothing but 2 half minus 1. If you can see how, let's say we have 2 bits. So the minimum is 2, which is 10, right? 2 power 1, which is 2 power 1. And the maximum is 3. And if you consider, let's say 3 bits, so basically 3 bits, we'll calculate the half. Half turns out to be 2. And these are some manipulations, okay? Don't try to think, okay, how would I think about that? Try to learn from here. Some things you have to learn as well. You can try to maybe find a pattern, right? It's not very intuitive. I understand that. But if you understood this solution, next time you will understand that, right? You just what you obviously this the intuition is this, right? You just make all bit, this is one, all zeros, and in the other case you will make all ones. That's a basic idea. This is the maximum, this is the minimum for 4 bits. This is 8, and this is 50. And that you have to manipulate things, right? And that's all, yeah. You calculate the low, calculate the high, S and E separately because we need this S for later half. Okay, so we need that. And then we initialize our maxi from S minus 1. Okay, start minus 1, we initialize. And then what we'll do, this is very, very interesting step, very important. If you don't do this, you will get a runtime error. Why? See, we are exceeding these limits, and these all are integer. Either you convert all of them into numbers, long long. We have did that, but यहाँ पे you can do two long long, or you can multiply with long long. This would create an error if you won't, if you do a simple integer thing, because it will create a out of indexing thing, because high, low plus high by 2. If you do directly low plus high by 2, this will create a problem. Try to think. It's a very famous interview problem. So instead of going like this, what we are doing is firstly creating a low, then we are doing a high minus low by 2. We are not exceeding. Firstly, we are calculating high minus low by 2. Okay. And then we are doing the sum. This won't exceed the limit. This is very important. And then palindrome we are calculating, and then this is how we are doing the simple. If the palindrome, we can move ahead, right? If this satisfies, we can increase our palindrome, right? Value we can increase, so we increase our value, and then we max out our max and whatever the mid value, and then, and if our max turns out to be greater than start, then we'll conclude this answer, right? So this is overall a beautiful question of implementation. Also, one more thing, I initialize count with 1 because 0 we always have to consider. So this is also important. And I think you easily understand how I calculate the max bit thing. So if you understood the solution, do let me know in the comments that, okay, I understood this problem very well. And yeah, I explained everything in detail, right? So, and also let me know the feedback what I can improve. And if you do like the video, please hit the like button and subscribe to the channel for further videos coming up straight away. Stay tuned. Bye bye.